Okay, so let's start vectors. The next unit. So you might be asked in your physics class to draw a diagram representing a force of 40 newtons in the direction in the northeast direction. And so you would make a diagram. You would use the Cartesian plane to make something that looks like this. You'd start at the origin. You'd draw an arrow, and you would label it 40n. And this is the idea of the vector. We see here we have this arrow, and it has a direction, and it has a specific quantity. So this is physics. Now, we're not in physics class. We're in a math class. So when we talk about a vector, we're going to talk about, in our class, the vector is going to have direction, but the quantity is going to be distance. So this is the idea. So let's get some words down. So the first thing is a scalar. A scalar is a quantity with only magnitude. So you won't, once again, or this, it's a fancy word for size. So in physics, you'll be talking about forces, 40 newtons. In math class, we might talk about that, but we're going to be talking about like 5 miles. So it's size. In calculus, we'll talk about speed, 10 miles per hour. A vector, which is what we're going to focus on, a vector is a quantity or quantities which have both direction and magnitude. And velocity, acceleration, force, displacement, momentum. So our thing in this class, well, in the first unit, we're going to be, our magnitude is displacement. Because once again, we're in a math class. We're going to be putting stuff on the Cartesian plane. We're going in that direction, like 10 miles. So that's what we're going to be doing here. This is a great beginning to work on your exploration, transfer this knowledge to physics or something else that for which a thing, the vector has direction and a size to it. Okay, so first of all, let's talk about vector notation. Vector notation. Okay, and the idea is we might see here. So the idea is we see this is O, and this is, let's call this A. And the idea is that it starts at the origin, okay, and ends at A. Okay, and we call this the position vector of A. It can be represented as, OA, or simply little letter A, but really bold. So this is the idea. Let me lower this. So that's what you're going to see vectors, the visual representation. The magnitude is the absolute value of A. Once again, this is a math class, so the distance is going to be the absolute value, or simply the absolute value of little a. Okay, please remember that a vector is a journey. It starts at the tail and ends at the tip. So let's get that down. A vector, so a vector is a journey. It starts at the tail and ends at the tip. So for example, if you see vector AB, we know that it starts at A and ends at B. That's the idea. It's all about the journey. It's all about the journey. Okay, well, let's go, as I say, let's go through like the grades. Let's start, so the question is, one or two vectors are equal. So let's see. So, let's see. Two vectors are equal if they have the same magnitude and the same distance, and the same direction. So, for example, and we could say that AB and BA are negative vectors, right? So it's the same length, right? Because so the magnitude is the same, but because the directions are different, they're not equal vectors. They're opposite vectors. Same length, but opposite direction. Nice. We could say that AB is equal to negative BA, right? Yeah. Let's look at example 2 in the book. So let's see. So example 2 in the book. Take a picture of this, please. Take a picture. Good. So the idea is we have this diagram. So it's two triangles. Let's see. So let's see. We have two triangles. So it's AEB and BDC. We see that AE is vector Q. We know that AB is vector P, and we see that DC is R. So let's get that written down. I'll put these up. Once again, we see that AE is Q. We see that AB, vector AB, is P, and we see that vector DC is R. Okay? And so the question is, which statements are true? Does EB equal R? So is this true or false? True or false? EB equals R. Well, that's true. Why is it true? Well, these are both, they're congruent. Let's see. They're two equilateral triangles. Yeah, they're equilateral triangles, so they're all equal. And let's see, what else do we know? Yep. So EB and DC go in the same direction. So if DC is R, EB is R. That's true. Next one, the magnitude of P is equal to the magnitude of Q. Well, let's see. It's an equilateral triangle, so the magnitudes are that's true. Are they the equal vectors? No, because they have different directions. What's going on with C? BC is R. BC is R. No, BC is not R. What is BC actually equal to? BC is actually P, but BC is not DC, and although the magnitudes are the same, DC and BC are going in different directions. False. Let's try another one. Let's see. DB is Q. Vector DB is Q. Let's see. No. DB. No. Although it's the same magnitude, they're going in different directions. AE is going up. DB is going down. They're not equal. They may have equal magnitudes, but different direction? No. False. What's next? ED equals P. ED equals P. Let's see. Yeah. Yeah, that looks good to me. Let's see. It's the same direction as AB. Nice, that looks good to me. True. Where's to my pen? Oh, there it is. Last question. P equals Q. Is that true? No. They have the same magnitude, but different directions. They're not equal. False. Good. Let's move on. Nice. Vector addition. So we now know that things are equal. Now, how do we combine these vectors? Nice. Let's keep going. Let's see. Vector addition. Vectors are all about the journeys. Let's see. Vector addition. Vectors. It's all about this. It's about displacement. It's how do we get from point A from the beginning to the end. So the idea is, if you're looking at, we're starting here, and we go along the first vector. That's A. So we tail, tip. Now we start the new journey. The new journey is B. Tail, tip. Well, we can claim that we have this vector here, and we're going to call this A plus B. So this is vector A, vector B, A plus B. Now, this confused me at first. Because I'm like, wait a minute, that breaks the triangle rule. How can the third side be equal to the sum of the two sides? No, that's not what's going on here. It's a representation of displacement. It's the journey. This represents the total journey. So that's the idea. That's what's going on. We're not breaking the rules of triangle inequalities. We're just representing the final displacement to get from here to here. It's vector A plus vector B. Once again, so when you see, sorry, let me go ahead. I'm really excited about this unit. I'm really excited. When you see A plus B, right? Immediately you say, okay, the first journey is A, and then the second journey is B, right? So let's take a look at example 3. So example 3, well, do we need to look at an example? Yeah, let's take a look at example 3. So obviously I'll put these in the book. Take a look. Let's see. Yeah, take a picture. Now you can see that we're starting to put our journeys on graph paper, and you can actually see. So the journey is there's a change in x and a change in y. And so the idea is, if you look at that example, let's say example 3, A, you can see the changes 3 to the right and 4 up. And I want you to think about what does this graph tell us about journey B? Journey B says, oh, go 1, 2, 3, 4 to the right and 2 down. So if we have we see A plus B, that's equal to 7 to the right and 2 up. That's the idea. So the idea, once again, these vectors, they just tell us about the journeys. Once again, if you look at the example, the vector A says you're going to go 3 to the right and 4 up. And then journey B says go 4 to the right and 2 down. And therefore the total journey, the first journey plus the second journey, is 7 to the right and 2 up. That's the displacement. That's the displacement. Once again, it's all about the journeys. Let's see. What happened to my notes? Let's continue. Nice. Zero vector. Okay. And we will continue with this. Let's see. Okay. Zero vector. What is a zero vector? A zero vector has a length of 0. So for any vector, a vector plus a zero vector results in like the original vector. Once again, this is the first journey. This is the second journey. We haven't changed. That's the idea. Same idea. 0 plus A equals A, and let's think about this. This is the identity, right? What would be the inverse? Well, if we add the vector, but then added the opposite, we get a zero vector, right? Once again, these are opposite. It's like going 3 miles this way and then going 3 miles back. Your displacement is 0. That's what's going on here. Yeah. Yep. Let's see. Example 4. Example 4 in the book. What is example 4? Let's see. Example 4. So example 4, let's take a look at this. Once again, I'll get it up there. Let's see. Nope, sorry. Here we go. Take a picture. Nice. So the idea is find a single vector which is equal to B plus C. So what's B, C plus CA? Well, where do we start? We start at B and go to C. Where's our next journey? Our next journey starts at C and ends at A. A single vector, BA. That's it. Let's try this one. BA plus AE plus EC. Well, once again, these are journeys. We start at B and go to A. In the second journey, we start at A and go to E. And in the third journey, we start at E and go to C. What's our displacement? B to C. Next example. A to B plus B to C plus C to A. A to B plus B to C plus C to A. Now, this is kind of interesting. This kind of starts to bring a point home, right? Yeah, can you see that? So we start at A and go to B. Second journey, we go to B and we start at B and go to C. Third journey, we start at C and come back to A. Well, A to A is simply what? That's 0. Now, This does not say, please remember, we're doing displacement, not distance. This doesn't say I didn't move. It just says I came back to where I started. That's what's going on here. So once again, imagine like I stand here, close your eyes. Now open them. Does it look like I moved? No, but you know, for those of you who didn't close your eyes, you know I moved around. So once again, you have to maintain that idea of distance versus displacement. Good. Let's go on. Vector subtraction. And I think we'll finish that for this video. What's going on with vector subtraction? Kids get freaked out by vector subtraction. It's very basic. So vector subtraction, so they see, vector A minus B. Well, first of all, I want you to always write your vectors as a sum of journeys. So we're going to rewrite this as vector A plus negative vector B. This is kind of cool. So once again, vector A and vector B are defined, but now we're told to go in the opposite direction of B. So let's make a diagram. This is A. So let's say that this is A and this is B. Right? This is the journey A and this is the journey B. So you say, okay, how do I write AB? Vector AB. So you say, fine. I start here, I go up there, and then I go down here. That's B. So this was journey A, and this was journey B. And therefore, my displacement, I'm going to find my red marker, or I'll use my green. This is this displacement of A plus B. But the question is, what is A minus B? No big deal. So if this direction was B, this direction is negative B. And therefore, very straightforward, this vector is A minus B. That's all it means. It just means the first journey is A, and the second journey is the opposite of B. That's it. Once again, this is A plus B. First journey is A, second journey is B. This is A minus B. First journey is A, second journey is the opposite of B. That's it. That's all vector subtraction is. Don't get freaked out by subtraction. Let's see. That's it. That's it. So, do I have something in the book? Yeah. Yeah, so what I'm going to ask you to do is I'm going to make copies of the problem in the book, and I just want you to look at these first few chapters, first few units. Good.